And here is talking about the acid and base worksheet. The top part is just using this information to match the answer, acid or base or both or none. Okay. Here the table is, I just got this information, okay, from the back of the page. Is I drop down the definition. Anhydrous acid is the acid give off H plus in H2O, and the H is always at the front. Anhydrous base is the base give off OH minus in water, and the OH is at the back. Brownstein lauric acid is the H plus donor, so it gives off H plus. Brownstein lauric base is H plus receiver, so they pick up H plus. You see that this H plus is on the right hand side as a product, so it donated. This H plus is on the left hand side of the arrow because it was picked up, it was received. So right here, there are some example. There's some like asking you what they are, what kind of acid, what kind of base. Sometimes it could be more than one answer. So for example, calcium hydroxide definitely is a base. Okay, so it's not AA or BLA. It is a anhydrous base because it gives off OH minus. But it is not a Brownstein lauric base because it cannot pick up an H plus. Because if you try to add an H plus, it cannot form something. Okay, so put it this way, you can try to add the H plus, and then if I add H plus, have I seen NH4? Right, NH4, because I have a plus sign, I will become a plus from the zero charge to become a plus charge. Okay, so did I ever seen an NH4 plus before? Yes, I did. NH4 is the ammonia, so it worked. HSL4 minus, if I add H plus, right, minus plus become no charge. If I add H on it, it becomes H2SO4. Have I seen HSO4 before? Yes, I can. I see. All right. So that is a Brownstein lauric base. You can try to add the H plus to see the new product. Have you seen that before? And just like the Brownstein lauric acid, it donates the H plus. So you can try, okay, HNO3. If I take away the H plus, I donate H plus. I take away the H plus, I will become a negative charge because this is supposed to be zero charge. I take away the charge, the plus charge become negative. And then I donate the H, so I become NO3 minus. Have I seen NO3 minus before? Yeah, it's a nitrate. Okay, so it worked. This is a Brownstein lauric acid. H2SO4, if I donate the H, I take away the H plus two of them, and I will form SO4 2 minus. Have I seen that before? Yes, I have seen it before. So you can actually try to work on the equation to see if you see the product before. Okay, if you do, then it is a Lausabard acid, Lausabard base. So right here, calcium hydroxide, can I, like a base meaning that it receives a H plus. If I add H plus, I haven't seen something like that before. So it is not the Brownstein lauric base. It's just a anhydrous base. H2SO4 definitely is a anhydrous acid because it can has an H in the front. And also, can I donate the H? Yes. If I take away the H, donate the H, two of them, I will form SO4 2 minus right here. I've seen that before. Okay, so right here. Okay, so it is also a BLA. So the Brownstein lauric one, you have to make it like an equation thing. Okay, either you give the H for the acid or you take the H for the base. And then the KOH is only AB, okay, is a OH. And if I try to add a H, it doesn't work. I haven't seen something like that before. Or let's see if I have NH3. NH3 definitely is not an anhydrous base because I don't have OH. But I can receive a H plus. Okay? I can receive a H plus and I've seen NH4 plus before. Okay, so this is a BLB because it picked up the H plus, it received H plus. And then HSO4 minus, this one is a, it has a H and it actually it is S. It is also a anhydrous acid because it has H before. All right, and also can I can it become a BLA? Yes, because it can donate. Let's say, HSO4 minus, I can donate the H. I can take away the H and I will form SO4 2 minus. Yes, I have seen SO4 2 minus before. Okay.